Hello everyone, myself Vinay Kumar. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I had started the new chapter in 10th standard mathematics. That was the chapter 1, which is based on real numbers. In my previous videos, I have explained about the fundamental theorem of arithmetic, and I have also solved examples from 1 to 4. So in this video, we'll be looking into the exercise 1.1 questions. So in exercise 1.1, in the first question, you have to express the numbers which are given in this first question as the product of prime numbers. So basically you have to express it as product of power of prime numbers. So the first question in this first question, they have given 140 as the number. So how to factorize 140? So you can just factorize 140 as 2 into 70. So you can write like this. So next 2 into 70 can be written as 2 into 2 into 35. Correct? So next you can write this as 2 into 2 into 35. You can split as 7 into 5. So 7 5s are 35. So 7 into 5. So 2 into 2 you can write as 2 square into 7 into 5. So this is the power of product of prime numbers of 140, of the number 140. So now we'll move to the second question in the same first question. So in second question, they have given 156 as the number. So 156 number we have. This also we'll try to factorize. So 156 means 78 into 2. So this 78 again you can write this as 39 into 2 into 2. So 39 can be written as 13 into 3 because 13 3s are 39 into 2 into 2. So that means here you can write this as 2 square into 3 into 13. So this is the factorization of 156. So now we will move into the third question. So in the third question, they have given 3825. So 3825 is there. So we'll try to factorize this. So 3825 you can write as 5 into, because 5 is the factor, because this number is ending with 5. So you can take 5. So 5 into 765 you can express this 3825. So now this 765 also you can write as 5 into 5 into, so here 5 ones are 5, 2 will be remaining 26, 5 5s are 25, 1 will be remaining 3. So now you have 5 into 5 into 153. So 17 into 9 will give you 153. So 5 into 5 into 17 into 9 will give you 3825. So now 5 into 5 I can write as 5 square. 17 I can keep like that. So 9 I can write as 3 into 3. So that means here we'll be getting 3 square into 5 square into 17. So 3 square into 5 square into 17 is the product of prime numbers of 3825. So there are two more questions in this first question, that is fourth and fifth question, that you can solve on your own. Just like this, how I solved first 3 questions, you can solve remaining 2 questions. So now we will move into the second question in this exercise 1.1. So in second question, you have to find out HCF and LCM of the pairs which they have given in this second question. So they have given 3 questions in this second question. So in that first question, if you look, so in first question, they have given 26 and 91. So they have given 26 and 91. So 26 and 91 they have given. You have to find out HCF and LCM. After finding out HCF and LCM, you have to verify whether HCF of A comma B, HCF of A comma B into LCM of A comma B is equal to A cross B. So this formula I have discussed in my previous video. You can refer my previous video. So this formula we have to verify after taking HCF and LCM of 2 numbers which they have given. So now here first we will try to factorize 26. So 26 can be written as 13 into 2. and 91 is there. So 91 you can write as 13 into 7. So here you have to take the common factor and you have to multiply all the common factors so that you will get highest common factor, that is HCF. So now here 13 is there, here also 13 is there. So 113 you can take, but 2 you cannot take because in 91 2 is not there, and 7 also you cannot take because in 26 7 is not the prime factor. So that's why the only prime factor in this question is, so the only common prime factor among these two numbers is 13. So now you have to take LCM of these two numbers. So here, which is having highest power in 13, in both the 13s, both are having same power, that is power 1. So 113 you can take, and 2 you can take, and 7 also you can consider. So 7 2s are 14. So here we are getting 13 into 7 2s are 14. So here 14 3s are 42. 14 3s are 42. 4 carry. 14 1s are 4. 4 plus 1. 14 1s are 14. 14 plus 4 18. So 182. So here LCM we are getting as 182 and HCF we are getting as 13. So now we have to verify this formula. 13, so HCF of A comma B. So here in the place of A we have 26 and in the place of B we have 91. Similarly here also we have 26 and 91. Here also we have 26 into 91. So here HCF is 13 into LCM is 182. So into 182. So we have to verify whether this is equal to 26 into 91. So here when we solve 13 into 182, we get 2366, and when we solve 26 into 91, we get 2366. So that means this particular formula is verified. So that means here this particular formula is verified. Like this, we have to solve for 2 more questions as well. So coming into the second question, in the same second question, here they have given 2 numbers, that is 510 and 92. So 510 and 92 are there. First I will write that. So 510 is one number and 92 is another number. Now we have to find out HCF of these 2 numbers. So in order to find out HCF, first we have to factorize these 2 numbers. So we'll take 510. So 510 can be written as 2 into 255. So 255, again I can write this as 2 into 5 into, so here 5 5s are 25, 1 is there, so 5 1s are 5. So 5 into 51 will give you 255. So now 51 you can again write this as, so 5 into 3 into, so 3 1s are 3, 2 will be remaining 7. So 17 into 3 will give you 51. So now we have got 2 into 5 into 3 into 17. So now we have one more number, that is 92. So this 92 also we have to factorize. So when you factorize 92, you will get 2 into, so 2 4s are 8, 1 will be remaining, 2 6 are 12. So 46, 2 into 46. Again this 2 into 46, you can write this as 2 into 2 into 23. And 23 is a prime number. So that means here you can see 2 is common in both of them, and 5 is not there, 3 is not there, 17 is not there in 92. Similarly, this one more 2 is not there in 510, 23 is not there in 510. So the only number which is there here as common between both the numbers, that is the only common factor which is there, is 2. So the HCF of this will be equal to 2. So the HCF is 2. And what will be the LCM? So LCM will be equal to, so 1 2 common is there, so 1 2 you can write. So one more 2 is there in this, so 2 into 23 you have to write, and 5 3 and 17 are there, so 5 3 and 17. So when you solve this, so when you solve all these numbers, you will get LCM 23,460. So 23,460 is there. So now we have got HCF as 2. We have got HCF as 2. LCM as 23,460. 60. So now we have to verify this formula, that is HCF into LCM is equal to A cross B. So what is HCF here? 23,460 is the LCM. So that is equal to A into B. What is A? 510. So 510 into B is 92. So when you solve this, you will get 46,920, and when you solve 510 into 92, that will also give you 46,920. So that means here the formula is verified. And remember, this formula is applicable only for two numbers. If you take three numbers, this formula will not be applicable. That I have explained in my previous video. So one more third question is there in this second question that you have to solve on your own. So after this, we will be moving into the next question in this exercise, that is third question. Now in third question, they have given three numbers. Again, you have three questions in this third question. So first we will be moving into the first question. So in the first question, in third question, we have three numbers, 12, 15 and 21. So now we have to use prime factorization method in order to find out HCF and LCM. So here 12, you can write this as 3 into 2 into 2, because 2 into 2 is 4, 3 into 4 will be 12. Similarly, 15 can be written as 5 into 3. 21 is also there. So 21 is equal to 7 into 3, because 7 3s are 21. Which is common factor in all these three? So 3 is common factor in all these three. And here 2 is not there in 15 and 21. And 5 is not there in 12. 7 is not there in 15 and 12. So that means here the only common factor in all these three is 3. So that's why HCF will be equal to 3. So now you have to find out LCM. So here 3 is common in all these. So you have to just take 1 time 3 into 2 and 2 is there. So that also you have to take 2 into 2, and 5 is there, 7 is there. So 5 into 7. So 7 5s are 35. 35 into 4 will give you 140. So that means here 3 into 140 will be getting. So 3 into 140 means 14 3s are 42. So 42 and 10 is there. So you can write that. So 420 is the LCM, 3 is the HCF. So now I will be solving the second question in third question. So in second question, you have three numbers. So the one is 17, second one is 23 and third one is 29. 23, 29. So that means here you have 17, 23 and 29. So now you can write this 17 as 17 only, and 23 you have to write as 23 only, because 17 is a prime number, 23 is also a prime number, and 29. So here 29 is also a prime number. So when you get all numbers as prime numbers, then how to find out HCF? See, one thing you should remember, this all factors will have 1 as its common factor. So that's why you can take 1 as the HCF. So here HCF will be equal to 1. And what will be the LCM? You have to take all the numbers because there is no common factor. So you can just take 17 into 23 into 29. So when you solve this, you will get 11,339. So here HCF will be 1 and LCM will be 11,339. So one more question is there in this third question that you can solve on your own. So now we will be moving into the fourth question in this exercise. So in fourth question, they have given HCF of two numbers 306, 657. So here 306 and 657 are the two numbers which they have given, and the HCF of these two numbers is equal to 9. So HCF of these two numbers is equal to 9. Now we have to find out LCM. So how to find out LCM? We can use the formula. So LCM of 306, 657 is equal to A into B, you have to do. So A into B is 306 acts as A and 657 acts as B. So 306 into 657 divided by this HCF value we have to take. So that HCF of these two numbers, that is 306, 657 will be there in the denominator. So that is you can write this as 306 into 657 divided by 9. So now here 3 3s are 9, 3 1s are 3, 0 will be there, 3 2s are 6. So now here again 3 1s are 3, 3 3s are 9, 1 will be remaining 12. So 3 4s are 12. So here you are getting this as 34 into 657. So if you solve this, you'll get the LCM. So when you solve this, you'll get 22,338 as your LCM. So here LCM of these two numbers is equal to 22,338. So now after this fourth question, we'll move into the next question, that is fifth question. So fifth question is very much similar to example 1. So if you refer my previous video, I have explained from example 1 till example 4. So example 1 how we have solved. Similarly, we have to solve this fifth question in exercise 1.1. So in fifth question, they have given 6 power n, where n belongs to natural number. So this symbol is for belonging to a particular set. So here n belongs to the natural number set. So that means here this n, if you substitute any natural number in the place of n, whether you will get a number which will be ending with 0. So this we have solved for 4 power n. Now we have to solve for 6 power n. So here always remember, if any number, if it is ending with 0, let's take 10. So 10 is ending with 0. If I take 100, 2 into 50 you can write. So this you can write as 2 into 5 into 2 into 5. Similarly, now if I take 50, 50 is also ending with 0. So that means 5 into 10 will be there. So 10 means 2 into 5. If you take the number 6, so 6 can be written as 2 into 3 whole power n. So 2 into 3 whole power n means the factors of 6 is 3. So here factors of 6 is 2 and 3. So here factors of 6 and 6 is 2 and 3, and here 5 is not the factor of 6. So first point is 2 and 3 are the factors of 6. Second point is, so 5 is not the factor of 6. So this is the second point which you have to remember. So since 5 is not the factor of 6, therefore, so for any natural number capital N for small n, so for any natural number capital N for small n, that means if you take any natural number and substitute in the place of small n, you will not get a number, so we will not get number which is ending with, so will not get a number which is ending with 0. So this is how you have to explain, or you can explain on your own words as well. So the first point is factors of 6 is 2 and 3. So that means here 5 is not the factor of 6, and so that's why here, since 5 is not the factor of 6, therefore for any natural number n, that is capital N, if you substitute in the small n, that means all the natural numbers, if you substitute in this small n and go on seeing the numbers what you will be getting, those numbers will not get the number which is ending with 0. So that means the numbers which we get when we substitute natural number in the place of small n, we will never get a number which is ending with 0. So that is the answer for this question. So these things you can write on your own, and you can refer my previous video also where I have explained the example 1 question. So now we will be moving into the sixth question in this exercise. So now in sixth question, they have given two numbers. So here the first number which they have given is 7 into, you have to solve this, 7 into 11 into 13 plus 13. So the second number which they have given here is 7 into, so the second one is 7 into 6 into 5 into 4 into 3 into 2 into 1 at last plus 5. So that means here they have given two numbers and you have to explain why these numbers are composite numbers. So in order to explain that, here 13 is there. So this you have to consider first and then you have to consider plus 13, because according to BODMAS rule, multiplication comes first and then the addition. So that's why here in 7 into 11 into 13. So 13 is there, plus in 13, 13 is there. So you can take 13 common in both of them. So you can take 13 common in both of them. So inside bracket you will have 7 into 11 into, so 13 you are taking common. So in the place of 13, 1 will be remaining. So 7 into 11 into 1 plus 1. So here again plus 1 will be there. So now we have taken 13 common. So 7 into 11 is 77 plus 1 will be 78. So here 78 into 13. So that means here already we are getting one prime number which is not itself or which is not equal to 1. So if you do 78 into 13, whatever the big number you are getting, that will be the factor of that number and 1 will be the factor of that number. So then only if these two numbers are the factors of a particular number, then that is a prime number. Other than that, it is composite number. So that means here, if I have 3 as my number, so 3 has factor 1 and 3 has factor 3. So that means here, this particular 3 doesn't have any other factor other than itself and 1. So that means 3 is prime number. But if I consider 4, so if I consider 4, 4 is factor of 1 is the factor of 4, 4 is also the factor of 4, 2 is also the factor of 4. So that means one more number we are getting other than itself and 1. So as the factor of a particular number, so that means 4 is a composite number. So here also if you do 78 into 13, already 13 is a prime number which is the factor of that big number which you will be getting when you multiply 78 into 13. So that means here this particular number is a composite number. So why? Because it has 13 as its factor. Because it has 13 as its factor. So now if you see this particular number, so here you can see 5 is there, here also 5 is there. So you can just take 5 common outside. So 7 into 6 into 4, so into 4 into 3 into 2 into 1 plus 1, because I am taking this 5 and this 5 common. So outside bracket there will be into 5. So this you can again write as, so this is the second part of the question. So when you do this, you will get 1008 plus 1 into 5. So when you solve this, you will get 1009 into 5. So here 1009 is a prime number and 5 is also a prime number. So when you multiply 1009 into 5, so you'll get 5 9s are 45, 4 carry. So 5 zeros are 0, 5 ones are 5. So you're getting 5045, and this 5045 has 5 as its factor and 1009 also as its factor. So that means other than 5045 and other than 1, it has 2 more prime factors, that is 5 and 1009. So that means here other than itself and 1, it has 2 more factors, means here 5045 is a composite numbers. So you can write this. So therefore 5045 is a composite number because it has 5009 as its prime factors. So now we will be moving into the 7th question in this exercise. So in 7th question, they have given here there is a circular path around a sports field. So that means here there is a circular path. So let me draw one circle here. So there is a circular path like this. So in this circular path, there are 2 students. So one student name is Somika. So you can take that person's name as S. And one more student's name is Ravi. You can take that name as R. So now Somika and Ravi starts from a starting point. Here Somika takes 18 minutes to drive through the circle. So Somika takes 18 minutes to drive through the circle and Ravi takes 12 minutes to round the circle. So that means they are taking different times, but they are starting at the same position at the same time. So same time they are starting, but Somika takes 18 minutes to finish, Ravi takes 12 minutes to finish. So now after how many minutes? It is 18 minutes and 12 minutes. So after how many minutes again they will meet together? Because when Somika will complete her 18 minutes, Ravi would have been already completed 12 and he has traveled 6 more minutes extra. So that means Ravi will be somewhere over here. When Somika completes her 1 round, Ravi will be completed his 1.5 rounds. So that is how that mismatch will be there. So that means here after how many minutes again they will meet at a particular point, not in the starting point, wherever, but you have to calculate after how many minutes they both meet each other while they are revolving around this circular path. So now here, in order to find that, you have to just take LCM. You have to just take LCM between 18 and 12, because that will give you the least common multiple. So when you get that least common multiple, that answer is the number of minutes at which both of them meet together. So now LCM of 18, 20. So LCM of 18, 12. So here you have to use prime factorization method. So 18 means it is 9 into 2. This you can write as 3 into 3 into 2. So that means here 3 square into 2 will be there. So now you have to take prime factorization of 12. So 12 you can write as 3 into 2 square. So 2 square is 4. So 4 into 3 will be 12. So here always you have to take, here you can see 3 is also there, here also 3 is there, here also 2 is there, here also 2 is there. While taking LCM, you have to consider the highest power in both the common factors. So here, while considering LCM, you have to take the highest power. So here highest power between 3 square and 3 power 1 is 3 square. So I have to take 3 square, and between these two 2's, which has the highest power, here this is 2 power 1 and here it is 2 power 2. So I have to take the highest power. So into 2 square. So 3 square is 9. 3 3s are 9. 2 square is 4. 2 2s are 4. So 9 4s are 36 minutes. So after 36 minutes, they both will meet each other once again. So this is all there in this particular video. I have solved all the questions which were there in this exercise 1.1. Few questions in first, second and third I have left for you to solve. So in my next video, I will be teaching the next concepts which are there after exercise 1.1. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.